Taco taste.
No, you can't. That hurts. Ouch! Here, do you want me to hit you with it?
Okay, so I want to give you guys a couple of examples of how to graph absolute values. So here is your first basic example. So y equals the absolute value of x. So I'm just going to make a table. That seems like the simplest way to start. So let's try to see what patterns we see. So when x equals 0, y equal, not 1, y equals 0. The absolute value of 0 is 0. When x is 1, y is 1. When x is 2, y is 2. Okay, easy enough. Now, here's where the absolute value is going to kick in. When x is negative 1, y is 1. When x is negative 2, y is 2. So what this looks like is, let's see, let's plot these points. So 0, 0, 1, 1, 2, 2. So it's just going to keep going in this direction. It's going to look something like that. The other side, negative 1, 1, negative 2, 2, and so on. It's just going to go like that. We call this point down here the vertex. So this guy down here is called the vertex. It's where it abruptly pivots. Now, the vertex will always occur where the value inside here is equal to 0. So in this case, it occurs at 0 because, when x is 0, we get 0. So let's do another example. So let's do something a little bit different. So here's example number 2. So let's look at that. Let's see what that plus 1 does. So again, I'm just going to make a table. And I'm going to play around with a few points. So let's see, negative 2, negative 1, 0, 1, 2. See what happens, 3. So when x is 0, 0 plus 1 is 1. When x is 2, we get 2, 3, 4. When x is negative 1, we get 0. When x is negative 2, when x is negative 2, so we get y equals the absolute value of negative 2 plus 1, which is the absolute value of negative 1, which is 1. So this is 1. Let me squeeze one more number in there. The absolute value of negative 3 plus 1 is this, which is 2. So 2. And here's what that graph will look like. So it's going to be a V, as we will see, but it will be a V that's been shifted. So let's see what that means. So let's just plot these points. So 0, 1, 1, 2, negative, let's see, 2, 3. Probably can see where this is going. 3, 4. So something like that. So let's go the other direction. Negative 1, 0. Negative 2, 1. And negative 3, 2. Something like that. So my graph is a V, as promised. But now the vertex is shifted. So now the vertex is at negative 1. Now why negative 1? Well, again, it turns out that where this quantity that I've circled inside the absolute value, where that quantity is equal to 0, that's where the vertex will be. So x plus 1 equals 0 when x equals negative 1. So that's, again, that's the vertex. Let's see. Let's do another example. How about y is equal to the absolute value of 2x minus 1. So this is going to be a little bit more subtle. So the reason for that is for the following. When this quantity inside the absolute value is equal to 0, so let's see, what is that quantity? So I'm going to add 1. I'm just solving this equation really quick. So 2x equals 1 divided by 2. So in this case, apparently my vertex is going to be located at x equals 1/2. So let's see how this develops. So again, I'm just going to make a table. So at 1/2, I'll put 1/2 right here. So at 1/2, we're going to get 0. So 2 times 1/2 is 1. 1 minus 1 is 0, so 0. Let's see what happens when I put in 1. So the absolute value of 2 times 1 minus 1 is 1. So I get 1. So for 2, the absolute value of that is 3. Let's see, one more here. All right, let's resize this a little bit. When y equals 3, I get 2 times 3 minus 1 equals 6 minus 1 equals 5. Okay, now let me go the other direction. When y equals, or x equals 0, I get 2 times 0 minus 1 equals 0 minus 1, which is 1. So it's going back up again. When x equals -1, I get 2 times -1 minus 1, which is -2 minus 1, which is -3, which is 3. And one more. When x is -2, I get 2 times -2 minus 1 equals -4, take away 1, which is 5. Okay, so that's the table I ended up with. So I'm going to erase this here so I have enough room to do what follows. Okay, so let's graph this. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So let's see. When x is 1/2, we get 0. So right here, sort of in the middle, we're going to get 0 or 1/2 1. When x is 1, we get 1. When x is 2, we get 3. When x is 3, we get 5. So it's doing something like this. It's a V again. And going the other way, when x is 0, we get 1. When x is -1, we get 3. And when x is -2, we get 5. So on the other side, made it a little crooked, but we get that. So the only thing that's really changed here, okay, so we shifted a half unit to the right, and I don't know if you can really notice so much from my graph, but the slope has changed. So the rise over run here, the slope is 2. So m equals 2 on this side, and over here the slope's negative, and it'll just be -2. Okay, so that is another example. So let me do one more example. So let's do something like this. Y equals the absolute value of x minus 2 plus 1. Let's see what that does. So again, the vertex will occur when this quantity inside of the absolute value is equal to 0. So it's going to occur when x minus 2 equals 0. So add 2, add 2. So the vertex is going to have an x coordinate of 2. Okay, so that's an important number. To the left of 2, it's going to behave one way. To the right of 2, it's going to behave a different way because the absolute value. So let's proceed with a table. So 2, when x is 2, the absolute value is 2 minus 2 plus 1, which is 0 plus 1, so 1. When x is 3, so 3 minus 2 plus 1 equals 1 plus 1, which is 2. When x is 4, 4 minus 2 plus 1 equals 2 plus 1, which is 3. So it's just 1, 2, 3. So let's go the other direction now. When x is 1, we got 1 minus 2 plus 1, which is the absolute value of negative 1 plus 1, which is 2. Because the absolute value of this guy is 1, so 1 plus 1 is 2. And then when we put 0 in there, so 0 minus 2 plus 1 is the absolute value of negative 2 plus 1, which is 2 plus 1, which is 3. Okay, so there's the table that we end up with. Yeah. That's the table that we end up with. So now I'm going to graph it. Let's see what that looks like. So okay, so when x is 0, y is 3. When x is 1, y is 2. When x is 2, y is 1. When x is 3, y is 2. So it's going back up. And when x is 4, y is 3. So it looks something like that. So it's still a v. The coordinate of the vertex is, in fact, as I said earlier, it's at x equals 2. But now it has a y coordinate. The y coordinate is 1. So the coordinate of this guy is 2, 1. And the 2 comes from this part right here, and the 1 comes from this part right here. Okay, so hopefully that made sense.